Hello, everyone. I hope you all are hanging in there and staying safe in these times. Today, we're moving on to lecture 11, and it is on databases. It's very useful, very hands on. Almost every company has its own databases for production data, for well log data, and all sorts of data. So, it's something very useful. Um, we're going to keep it very practical. So we're going to be working on real production data from the ball field. It's going to be interesting, so stay tuned. These are your learning goals, outcome, assessment, and activities. And with that, we get started. What is a database? It is a structure that stores information in an organized, consistent, reliable, and searchable way. So it's important that your data is organized and easily retrievable so you can search through all of the database for one item very quickly because of the organized structure. Once you go beyond basic computer programming, you will need a database. And I know I have lots of Python programming experts, and we're ready to get in to learning about databases. They provide a consistent way to access data in an organized structure, and this is the key word. It's for storing and retrieving large amounts of data. So storing is one part, retrieving the data is the other part. And databases provide the consistent structure to make that possible. Databases allow programmers build more complex apps that can take orders, process payments, make recommendations, authenticate users, and do all these complicated functions. So it's very important to be able to leverage the resource we have in databases from our Python codes. And that's what we're going to be doing in this topic. A database gives us a way to add structure to data and to define rules that the data must follow. It's the rules you define that gives you the organized, consistent structure in databases. Why use databases? Well, like I hinted on the previous slide, databases allow us to work with large amounts of data efficiently. So not only are you able to work with large data sets, but you're able to do that efficiently. So retrieving data is very fast because the databases provide a structure that makes that possible. They make it easy to update data and make the data in the database reliable and ensure accuracy. Databases offer security features to control access to information, and they avoid redundant data. So not only does your database facilitate storing and retrieving information, they also control who gets to access the information in the database. So you will hear of read access, which means you can retrieve information from the database, but you don't have write access. You can't modify the database. That's one access level. You can also control access such that certain users can modify certain parts of the database. And typically there will be one guy who will have admin privileges, administrative privileges, and that person will be able to modify all of the database. So you can have different layers of access to information, and that falls under security features, which is made available through databases. The type of database we will be focusing on is called a relational database, and we will talk about that shortly. These are used in many applications ranging from banking and other processing systems to mobile apps in content management systems like WordPress for those of you who are bloggers, right? And with your knowledge in this course, you can actually develop mobile apps using Python, because Python is very flexible. It allows you to do mobile app development. It also allows you to do web app development. So we're going to look at a case study which is going to show what databases bring to the table. So if you're a restaurant manager and you want to reward loyal customers with discounts on certain dishes, easiest and traditional approach, if you have just a few customers, you could write down the data for each customer on a note card like this. So you have like flashcards with each customer's information, and this will be the information the customer gives you. So this guy gives you his name, first and last name, and phone number only. This other guy gives you his name, his date of birth, and his email address. So you have different information, but all of them give you the name, right? So you have all of this stored on, written out on flashcards, and you could check out their information and do what you have to do, provided you have just a few customers. What will happen if you have a million customers? You will have a million flashcards. What if you have 1 billion customers? Then you see it's meaningless at that point. How will you search for God's holy land in the middle of all of those million or billion data sets? It becomes unwieldy and things get messy very quickly once you have lots of customers. And that's where databases begin to become appealing. But before you use databases, one could argue, why can't you just use spreadsheets? I mean, you can type the names and all of these in a spreadsheet. You have one column for the first name, another column for last name, a column for email, a column for date of birth, a column for phone number, and that solves the problem. Well, that also has its own issues. So let's start out with spreadsheet. So instead of the flashcards, we store the names like so, emails and everything. Some customers don't give you their phone number, some don't give you their email and on, but you have a row for each customer, a row replacing each flashcard. Now you can have a million in a spreadsheet, right? In database terminology, each of those rows are referred to as records, while the columns are fields. So first name is a field, phone is a field because it is a column in your spreadsheet. The records, Michael Jordan's information, will be one record in your database, in this case in your spreadsheet. The empty cells will be referred to as being null, so they are null, whereas these other guys are not null. So you can check for null to know which of the fields are missing for the different customers. So this appears to be all nice and good, but what if we want to keep track of every dish? I mean, keep track of which dishes each customer has ordered in the past. So one easy way out will be to have one more field for each order the customer has made in the past. So order one could represent the order I made a year ago, order two maybe a week ago. And you see this gets messy very quickly, right? If you've had a loyal customer who has been visiting the restaurant for the past 15 years and he has ordered about 2,000 different dishes in the past. So are you going to have 2,000 extra fields in this database? It gets very ugly. And many of the orders will be repeating too. So even the use of spreadsheet will not suffice. We need something more. What we need is database. So here I'm illustrating how you could use extra columns to keep track of previous orders the customer has made in the past, and they're shown here. But like I said, it's not efficient because it's going to be repeated and it could get very messy quickly when you have several orders the customer has made in the past. And many of them will be redundant information because they are just the same orders. So what are the benefits of structured data? You can get to use multiple tables. So those extra columns we were going to add for the different orders, what if we created a different table and we call it orders table, and it contains the menu of the restaurant basically. So you will see each restaurant has a finite number of items on the menu. You store those in one table. So that avoids the repetition, right? So every customer here is going to pick from these items in the order table. The previous spreadsheet is now stored as a table called customers. So this is the customers table, this is the orders table. Notice that we use the convention of pluralizing the name of the table. So customers in plural, orders in plural. It's just a way to make it easy to know that you're dealing with a table rather than the records in the table. So the meal orders can be considered as separate cards or separate tables. And these collection of rows and columns are called tables. Here you have only one column, right? Multiple rows, but one column. You could have another column, which we'll talk about shortly. And a database can contain more than one table, which in this case we have just two tables, customers table, orders table. And the databases offer the ability to create relationships between tables based on the rules you define. So it's okay to have two tables, but they better be related, which is a concept in relational databases. We're going to relate these tables, right? We know these customers will make orders from this menu, basically. So we will encode that information in our database. The structure of tables in a database is called a schema. So when you hear of database schema, yes, it refers to the structure of the tables in your database. By adding a unique identifier for each table, we can now connect the customers table to the orders table. What is the unique identifier? This order ID. So it's unique because you start from 1 and you keep increasing. You never repeat a number. So order ID is unique for every item in the orders table. Customer ID is unique for every item in the customers table. And you notice this is customers, this is customer, singular ID, order ID. That's the traditional convention for your keys. So these are called keys, and you will see on the next slide we'll talk about primary and secondary keys. So this is the primary key because it's unique. It's one and it keeps increasing for each item in the order. This is customer ID, which is the primary key here. So in this orders table, it is a foreign key. So it could repeat. Why? Because customer number 3, Kobe Bryant, could have classic burger on its menu. It could also have onion soup. So it could be repeated. So this customer's ID or customer ID only has to be unique in the customer table. But in other tables, it doesn't have to be unique. The unique ID is the primary key, which is the order ID right here. So that's what allows you to easily connect these two, so that if any customer orders a certain order ID, you already know what he ordered, and you don't have to repeat the orders like you would have had to if you use spreadsheets. So now, formal definition of the keys. A key is a value we can use to refer to only one specific row or record. So it's unique. The key is your unique identifier. Here, 1, 2, 3, and on increases monotonically. Same deal for order ID. This is the key in the orders table. This is the key in the customers table, right? And like I said, customer ID is the primary key in the customers table. But in the orders table, it is a secondary key. And in the orders table, it could be repeated. The primary key is the one that isn't allowed to repeat, and that is the order ID in the orders table. It's also possible to combine both primary and foreign keys and have composite keys, but we're not going to get to that in this course.